This is section 11.2, Arithmetic Sequences and Series. Our objective today is I can evaluate an arithmetic sequence and arithmetic series. Let's review the parts of a sequence or series. A sub 1 is always going to be talking about the very first term in the sequence or the series. D is going to be the difference, so that's going to be the constant that we're adding each time. A lot of my students like to think of this as the distance between each of the terms. N is going to be the number or the term that we're talking about. So if I say the 5th term, then N would be 5. If I say the 10th term, the nth term would be 10. And then A sub n is going to be the value of the nth term. So if I'm referring to 5 as the term, then A sub n is going to be the value of the entire sequence or the entire series after I've plugged 5 in. So for an arithmetic sequence, A sub 1, A sub 2, A sub 3, and so on and so forth to A sub n, in which the common difference is D, you can use this equation below to find any term in the arithmetic sequence when you know A sub 1 and D. In example 1, we're finding the nth term. We're finding the 12th term of the arithmetic sequence 9, 16, 23, 30. So step 1 is that we have to find the common difference. So how much are we adding between each term? And to get from 9 to 16, we're going to be adding 7. To get from 16 to 23, we'll also be adding 7. And to get from 23 to 30, we will also be 7. Or we'll be adding 7. So the common difference, D, is going to be 7. Now we can go ahead and use our formula. So we know that we want to find A sub 12 because they're asking for the 12th term. So that's what we're finding. We know that A sub 1, which is referring to our first term, is 9 because that's the first term in the sequence. Plus, we know that D is 7 because that's what we just found. And then N, we want the 12th term. So we're going to say that N is 12 because that's the term that we're finding. So now we can go ahead and simplify this. A sub 12 is equal to 9 plus 7 times 11. A sub 12 equals 9 plus, and we know that 7 times 11 is equal to 77. And so we know that A sub 12 is equal to 9 plus 77, which is 86. And that's going to be our final answer. In example 2, we're writing equations for the nth term. So what this means is we're going to be writing equations where we leave the value of n in the equation. That way, if I ask you for the 100th term, all you're doing is plugging in 100 for n. If I ask you for the 6th term, all you're doing is plugging in 6 for n. So this is a general formula that we're writing. So what we want to do, I wrote our equation up at the top right-hand corner, and then you don't have to worry about memorizing this. You will be given this formula for any quizzes or tests that you have to take. So we want to go ahead and start off with that formula, filling in what we know. So we know we want to leave A sub n in the formula because we're writing it for the nth term. So we want to leave n how it is. A sub 1 we know is going to be 5 because 5 is the first term. Plus D in this case is negative 18 because to get from 5 to negative 13 we have to subtract 18. To get from negative 13 to negative 31 we have to subtract 18. So in this case our D is negative 18. And then we know we want to just have our n minus 1. We're leaving n because it's our general formula. And now all we have to do is simplify. So we end up with A sub n equals 5 plus negative 18n plus 18. And I got that from distributing my negative 18 to both pieces. And now I can just combine like terms. So 18 plus 5 gives me 23, and then minus 18n. And this will be our final answer. We can go ahead and do that for the second equation as well. So again, we want to start off with our formula. Now this time is a little bit different because they gave us some information. So when they give you information, you just want to plug in what they gave you. So a sub n in this case, they gave us a sub 5 is equal to 19. So that's what we want to start with. And that means that we know that our n value is going to be 5 because they gave us a sub 5. So now we'll go ahead and plug in what we know. We don't know a sub 1 in this case, so we have to leave that as it is. They gave us d as 6, and then we know that since they gave us a sub 5, n will be 5. So before I can write my general rule here, I have to find out what that a sub 1 is equal to. So if I go ahead and simplify this, I have 19 equals a sub 1 plus 5 minus 1 gives us 4, and 6 times 4 gives us 24. And then I can subtract 24 from both sides. And 19 minus 24 gives me negative 5. So a sub 1 in this case is negative 5. So now I'm going to write my general rule, leaving my n's in the equation. So I have a sub n equals negative 5 plus, they gave me d was 6, and we're going to leave our n's this time, so n minus 1. And now, again, I'm going to simplify. So I have a sub n equals negative 5 plus 6n minus 6, and then I can just combine my like terms. So a sub n equals negative 5 plus negative 6 is negative 11 plus 6n. And that will be my final answer in this case. Sometimes you are given two terms of a sequence, but with a few terms missing in between them. These missing terms are called arithmetic means. The common difference d can be used to find the arithmetic means. So in our example, we see that they gave us negative 8, and then they gave us 4 blanks in between, and then they gave us 22. So we have to use that information to find out what those question marks or what those arithmetic means are. So we want to go ahead and start off with our formula, plugging in the things that we know. We know that a sub 1 is equal to negative 8. And then the only other piece of information that they gave us was this 22. And if we count, we know that 22 is the first, second, third, fourth, fifth, sixth term. So we know that a sub 6 is equal to 22. That's the only information that we've been given. So now I can plug this information into my equation. So a sub 6 is 22. So we'll go ahead and say a sub n is 22, and that's talking about the sixth term. And then a sub 1 we know is negative 8. We do not know d in this case. And then n, since we know a sub 6, we know that that's talking about the sixth term. So we'll go ahead and plug in 6 for n. And now we can go ahead and solve for d in this case. So if I simplify, I have 22 is equal to negative 8 plus 6 minus 1 is 5d, or d5, either way you want to write it. I'm going to go ahead and add 8 to both sides so that I end up with 30 is equal to 5d. And then I'm going to divide both sides by 5, and 30 divided by 5 gives me 6, so d is equal to 6. Now we're not done because they didn't ask for the difference. The difference is just used to help us find those question marks, or the arithmetic means. So since d is the difference, I can go ahead and say negative 8 plus 6 to get my next term. And if I have negative 8 plus 6, that's going to give me negative 2. Then I'll take negative 2 plus 6, and that's going to give me 4. Then I'll have 4 plus 6, which gives me 10. 10 plus 6, which gives me 16. And you always want your arithmetic means to match up with the number of question marks that there are. So we have 1, 2, 3, 4 question marks, and now we have 4 numbers. And just to make sure we've done this right, I always like to add 6 to my last number and see if it does actually give me that last number, that 22 that they gave me in this case. So 16 plus 6 does equal 22. So our arithmetic means are negative 2, 4, 10, and 16. A series is formed when the terms of a sequence are added. An arithmetic series is the sum of an arithmetic sequence. The sum of the first n terms is called the partial sum and is denoted by S sub n. Looking at why we have two formulas, you can use either one of the formulas to find the sum, but sometimes one will be easier than the other one to use. So in this case, in example 4, they want us to find the sum of these numbers that they gave us, so this sequence of numbers. And so we want to look at the two formulas we could use. We could use one that has a sub 1 and d, or a sub 1 and a sub n. It doesn't really matter which one we use. So for this one, let's just go ahead and use the first one. And so we know that we need a sub 1 and d. We know that a sub 1 is equal to 12, because that's our first term. And we know that d, to get from 12 to 19, we'd have to add 7. And to get from 19 to 26, we'd have to add 7. So we know that d is 7. So when I go to fill this out, I'm going to have s sub n, which is what I'm solving for, equals n over 2. Now that's a problem because I don't know what n is. So I'm going to have to figure that out. Then I have 2 times a sub 1, which is 12, plus parentheses n minus 1. Again, I'm not sure what n is, so I have to figure that out. And d we know is 7. So now I have to go and use my other formula, my a sub n formula, to be able to figure out what n is. So if I have a sub n, we know that my last term is 180. And I want to know which term that is. So I'm going to plug in 180 for a sub n. And then I have a sub 1 plus d times n minus 1. And now I can solve for that n. So I'm going to have 180 equals 12 plus 7n minus 7. And 12 minus 7 is going to give me 5. And then I'm going to subtract 5 from 180. So I'm going to have 175 equals 7n. And if I divide both sides by 7, so 175 divided by 7, that's going to give me n equals 25. So now I can plug in the n that I needed. So 25 and 25. And now I can solve for s sub n. So 25 divided by 2 is going to give me 12.5. And we're going to have 25 minus 1 times 7, which is going to give me 168. And 2 times 12 is 24. 24 plus 168 is going to give me 192. And then I need to just multiply that by 12.5. And that's going to give me 2,400. And that's going to be my final answer. So what this means is if I took this sequence of numbers and added all of them up from 12 all the way to 180, I would get 2,400 for my answer. In example 5, they want us to find the first 3 terms of the arithmetic series in which a sub 1 is 7, a sub n is 79, and s sub n is 430. Since they gave me a sub 1 and a sub n, I'm going to use the second formula because that's the formula that has a sub 1 and a sub n in it. So if I use that second formula, I'm going to plug everything in that I know. And I know that s sub n is 430. N, we don't know what n is, so I have to leave that as n over 2. And then a sub 1 is 7 plus a sub n is 79. So now I need to solve for the value of n. So if I have 79 plus 7, I'm going to get 86. And I can go ahead and divide both sides by 86. And 430 divided by 86 gives me 5. So 5 is equal to n over 2. I'm going to multiply both sides by 2. So n is equal to 10. Now that I know n, I can solve for d by going back to our formula. A sub n, which we know is 79, equals a sub 1, which is 7, plus d, we don't know d, times n minus 1. So here, if I go ahead and simplify, I'm going to have 79 equals 7 plus 9d. I can subtract 7 from both sides, so I end up with 72 is equal to 9d. And then I can divide both sides by 9, and that's going to give me d is equal to 8. Now keep in mind they didn't ask for d. They asked for the first 3 terms. We know that the first term is 7 because they gave us that at the beginning. And now, since the difference is 8, we know that we can add 7 plus 8 to get the second term, and that's going to give me 15. And then to get the third term, again, I can add 8, and that's going to give me 23. So the first 3 terms of the arithmetic series is 7, 15, and 23. Sometimes you're going to be asked to find the sum of a series using sigma notation. So looking at what sigma notation is, the bottom number is always going to be your starting point, and the top number is always going to be your stopping point. And then the piece to the right is always going to be the function that you're actually using. And then you have a nice little chart here that says how do you find a sub 1, how do you find a sub n, and how do you find n. So again, we're going to have to use one of our formulas, one of our S sub n formulas. And actually, in this case, I'm going to use the second one, because to find d, we would have to go all the way back to our arithmetic sequence formula. But if I don't use that formula, the first one, if I use the second one, I won't have to go find d. So, using our formula, we have S sub n equals n over 2 times a sub 1 plus a sub n. So I need to find a sub 1. Now this says I need to plug in the bottom number to get a sub 1. So to get a sub 1, I'm going to be taking my bottom number, which in this case, k is equal to 4 on the bottom. So I'm going to plug that into my function. So I'm going to have 6 times 4 minus 1. And that's going to give me 23. Now I need to find a sub n. A sub n I get from plugging in my top number. So 18 is my top number, so I'm going to have 6 times 18 minus 1. And 6 times 18 is going to give me 108, minus 1 is going to give me 107. Now I can find n. N is going to be the top number, so 18 is our top number, minus the bottom number, which is 4, plus 1. 18 minus 4 gives us 14, plus 1 gives me 15. So now it's literally just plugging our numbers into the equation. So we have S sub n equals n over 2, 15 over 2, times a sub 1, which is 23, plus a sub n, which is 107. So 107 plus 23 gives me 130, and I have to multiply that by 15 over 2. So 130 times 15 over 2 is going to give me 975, which is going to be my final answer, and in this case, our answer is C.